Time to look at another example of simplification and re-expansion. We're just going to amp it up just a little bit, no pun intended. We're going to make the circuit a little bit bigger, and we're going to be looking for a current that's at the far end of the circuit. So you can see here in figure 2, in figure 2A in particular, I have a voltage source, 9 volts, and then 4 resistors. I'm looking for the current through the far rightmost resistor, and then I would also like to know the current I1. I got to tell you the I1 is just going to be easy. That'll be part of the calculation of I sub A is to find I sub 1. I sub A is the real target here. So as we're working, that's a good thing to remember. Now, of course, when I look at this circuit, I'm looking for anything that I can combine in series or parallel. And I believe that in this whole circuit, only the 8 ohm and the 10 ohm resistors here can be combined. They're combined in series. So when I combine those, I'm going to add the resistances. I'll get 18 ohms, and that's shown here in figure B. Notice that because these resistors were in series, they had the same current flowing through them, and therefore I sub A still appears in figure B. That's something that is kind of a little blessing here, that we didn't have that in the first example, but I sub A will persist into figure B, as well as, of course, I sub 1, because we didn't make any changes on that end of the circuit. When we go from figure B to figure C, though, we're going to combine the 18 ohm and the 20 ohm resistors in parallel, and as soon as we do that, we'll get a 9.47 ohm resistor, and we can no longer label I sub A anywhere on figure C. It just simply no longer exists. We're left then with 2 resistors that we can combine in series. We get 19.47 ohms. I sub 1 is still on the circuit diagram, which is really good. If it weren't there, we would have to draw it in so that we could move that information back to the beginning. So I've got a 9 volt source, I've got a 19.47 ohm resistor. I can just calculate the current that flows here using Ohm's law. And so 9 volts divided by 19.47 ohms gives me 0.462 amps. Now, we've completed the simplification stage. We've gotten it down to the point where we've learned a valuable piece of information. We've learned the value of I1. And that value of I1 is the same in all 4 of these pictures, in all 4 of these circuits. Now, you might say, do we need to go all the way back to figure A? We certainly could go back to figure A, but figure B is our best target. Figure B is the last appearance of I sub A. It's the simplest circuit that still contains a representation of I sub A. As a matter of fact, it is a perfect representation of current division at the top center node. We know the value of the current that's flowing in from the left. We know that part of it's going to go down through the 20 ohm resistor, part of it's going to go down through the 18 ohm resistor. We can use current division to calculate the value of I sub A. So I sub A will be the total current coming in from the left multiplied by a ratio, which is the other resistance, 20 ohms, divided by the sum of 18 ohms plus 20 ohms. And when we do that, we get this equation here. We have 0.462 amps, the quantity that we just found in the previous calculation, multiplied by the other resistance, divided by the sum of the 2 resistances. That gives us 0.243 amps. So we were asked to find I sub 1 and I sub A. We found I sub 1 in transit to finding I sub A. That was great. That was half the thing we were asked to find. We just found by accident on the way to the other thing we were asked to find, which was I sub A. So you now have enough information to tackle the second example problem. If you're feeling really good, you could try the third one, but let's come back and I'll show you a more complex example that will prepare you for the third example problem. But you should be able to do the second example problem on your own and then go back and watch the video to see if you got it complete. At this point, the most important thing you can do is to develop the experience of having solved several of these problems on your own. You'll have some time to do that in class tomorrow, but this example right here is a place where you could tackle it on your own, and I would encourage you to try to do so.